Hi guys, welcome to Learning Electronics Repair. I have an oscilloscope here. This was sent to me by ToolTop. This is the ET120MPro. This is a single channel handheld oscilloscope. It also has a built-in signal generator, and we have some specifications. Let's have a look. Well, there's a sticker over the part I probably want to read, but this claims to be 120 megahertz oscilloscope. There's another similar model from ToolTop, which is the ET120M. This is the ET120MPro. I believe this is a relatively new product. And they've sent me this, asked me if I will test and review this. So I'm going to do pretty much the same as I do with all other oscilloscopes. We'll do some basic checks. We'll take a RF signal generator, see how well it works at high frequencies. And we'll also try a few real life situations as well. We'll just get into the bag. First thing then, it's small. Now this is small compared to quite a lot of the handheld scopes I've used. There's a little switch at the bottom of it. So this is an on-off switch. So this has a physical on-off switch. That might seem a bit old-fashioned, but that means that you don't need a standby supply all the time just to keep part of the circuit powered up so you can hold the button to start it, okay? So I suspect that actually increases the battery life, especially if you're using this in your toolkit on an ad hoc sort of basis. So with occasional use, it's not going to go flat before you want to use it the next time. So I actually quite like that, although it may seem like old tech. I don't have particularly large hands, and that fits very nicely into my hand. We can actually take a quick look. So it's 12 centimeters high, about just under 8 centimeters wide, and 3 centimeters deep. So that's actually quite a small scope. External connections, well, we have something here. Yeah, the ubiquitous USB-C. So this will be charging from USB-C. And apart from that, we just have what looks like an earth tag, and we have the BNC connector for the scope probe. Comes with a USB-C lead. I've switched this on from receiving it, by the way. The battery's fully charged. This is partly due, as I was saying, to the fact it doesn't require any sort of standby voltage. And we have a standard oscilloscope probe, 110 times. The manual is quite slim. Single language, English. Let's have a look at some of the specifications of this. Well, it starts off by telling us that when measuring unknown voltage, you have it in 10 times. I did notice online that it said this measures up to 80 volts on the 1 times and up to 800 volts on the 10 times. Bandwidth on the 1 times probe is 5 megahertz. Bandwidth on the 10 times is 100 megahertz. They do say this is a 120 megahertz scope, so take that as you will, okay. This is normal. You have to also set the oscilloscope to 10 times position. Now it goes back to mentioning 120 megahertz. Maybe this is the rating of the oscilloscope and this is the rating of the probe. That's what I think. The cost of this oscilloscope is in the region of $60 or so. I found the ET120M at that price. I was struggling to find the ET120MPro, but I am reviewing this just prior to release. But I do believe it's around the same price. And in actual fact, there is a link with a special offer in the description below. So if you like this, it's not an expensive tool. And you can save yourself a bit of money by using the link. Okay, so It's very light, almost no weight in this. That's another thing I've noticed. The screen is very clear, coming out very well on my overhead camera. Not much reflection unless I actually get the overhead fluorescent lights, of course, shining directly on it. Let's connect a probe to this and let's have a quick look to see what it's doing. So just quick thing, touch the end of the probe. It's saying on here 1 times. This is actually set to, oh, so let's put it on 1 times as well. Yeah, something's happening there. I guess we can actually change the settings, but let's just try auto. And it says that, it just took a while adjusting. So it's not actually picking anything up as such on that. We set at 5 volts per division. Let's see if we can just change that without looking at the manual. We'll see. So, yeah. So this is voltage, setting up and down. Very intuitive. This is the time base up or down. So yeah, this is very intuitive. Take it down to 50 millivolts as the lowest. And now it's picking up the stray noise I would expect it to pick up. I will say this adjusting does take some time. Okay, I think now it's gone back to 5 volts. I'm not quite sure that the adjusting is really working the best. Okay. Let's connect this to my signal generator and let's see what that shows us. I have my signal generator set to 1 kilohertz and I'm seeing the signal on the scope. I'm seeing the voltage, nothing on the frequency display. So let's hit the auto button. Yeah, and there we have a clear sine wave, 1 kilohertz. We can see the voltage peak to peak. 439 millivolts, and I can actually adjust that on the signal generator anyway. So the little oscilloscope locked on just fine to that signal. Let's go up to a higher frequency, something like 1 megahertz. Okay, so 1 megahertz. This is just going up to a line here. Again, I'm going to hit the auto function. And once again, we have a signal at 1 megahertz showing quite clearly on there. This signal generator isn't the best there is out there. It's a cheap one. The amplitude isn't constant across the frequency range, but we can push this up to 10 megahertz, which is the maximal for the generator. We can see the scope following, so 2 megahertz. It's kind of jittery a little bit on that, almost set to 3. Bear in mind, this isn't calibrated anyway, by the way. I have no reason to expect it's wrong, but I've had it for 10 years and it's never been calibrated. Let's hit auto. Yeah, and it's locked onto it again. Let's go up some more. 4. The oscilloscope follows that quite easily. 4 megahertz. 5. 6, 7. So it seems after you've moved quite a distance away in frequency from the point you hit auto, just hit auto again. 7, 8, 9, 10. And we're at the maximum setting for the signal generator. So I'll get the RF generator out and let's try this at some very high frequencies and see whether we can actually get up to 120 megahertz or not. I've connected my little RF signal generator. At the moment it's on 7.2 megahertz. This is just basically like a bare PCB. It's something that I built. Really wants putting into some sort of enclosure. I'll hit auto on the scope and he's picking it up at the sort of 7.14, 7.24, which is approximate to the frequency I have on the display. You'll see the display is not very stable, but at the moment I have this set to 1 times and the probe is set to 10 times. So let's just change that. So we're now on 10 times. Yeah, I can trigger on it, 7.24. Now this signal generator is not very good in respect of the shape of the waveform. It's really a clock generator that's kind of being used as an RF signal generator. Okay. I think I have some sort of like low frequency noise in this signal, which is causing it to do that. So we can just yeah, you can see it there, like a ripple in the waveform. That's probably because this is just sitting on the anti-static mat. Let me just try to raise it up a little bit. Yeah, I still have that noise, but again, that's the signal generator. It's interesting to see how this little oscilloscope actually responds to that, and it's doing a reasonably good job of it, to be quite honest. Let's go up into the next band. So we're now on 10 megahertz. You'll see the generator gives a much more accurate sine wave at the higher frequency. Let's go up again, 11.7. The oscilloscope is following it quite well. Up at 13, we'll hit the auto. Yeah. Yeah, we can trigger and lock it quite well, okay. Let's go up some more. So we're now at 14.1, 15, 17.65. Just trigger it again. And now he's having some trouble triggering on that. Just thinking about it for quite a long time. Okay. This time it got it. So it appears that the triggering has to have several attempts. This may be due to this low frequency noise in the signal. We're up at 21.5. This is saying 21.7. 27.015. Okay. 28.4. 50 megahertz. Let's try that. Again, it takes a few attempts to lock it with this amount of noise in the signal. But it does effectively measure it. It tells me it is there. Go up again. So this is now at 100 megahertz. Yeah. The rated maximum for this is 120. I can just move along a few digits. Step 1 megahertz. I can go up 1 megahertz at a time now. So 101. That's set to 102. Let's just see what it thinks of it. Again, you see we have to trigger that a few times. Well, to be quite honest, that's a nasty waveform. And it's got it, but it thinks it's 50 hertz. That might be the low frequency component it's actually seeing in the signal. I said there was a lot of noise in this signal at main frequency. I've tried to correct the grounding of the probe. So let's have another look. Well, okay, we have it again, the 7.2 megahertz. Let's go up again, and you can see I've got rid of that noise in there now. It was interesting to see how this scope reacted to that. It was doing pretty well considering what was going on. So up at 11.7, 13.6, 14.1, 15, 17.65, okay, 21.7 it's saying, 27.01. So I'm going to hit the auto again and see if it'll actually give me a more accurate reading. Yeah, 27.0. So it looks like if you want to measure the frequency, you should hit auto just to get a good reading. Okay, 28.4, 50. Once again, let's hit the auto, see if it will lock on that. No, let's go again. Thinking about it. Didn't get it. Yeah, it does seem that at high frequencies, that like now at 50 megahertz, this has problems locking on. If I keep trying, it may do it like this, but to be quite honest, by this point, if you're fault finding, you may well already have decided you don't have a signal. So that is certainly a limitation with this when we get into these high frequencies. Yeah, I can trigger it quite well. Yep, I can lock it quite well. Let's go up again. So we're going to go up to 100 megahertz now. 100 megahertz. And it's showing us 100 megahertz as well. Okay, we can see there's a signal there. Now I can adjust the generator 1 megahertz at a time. So let's do this and let's see what's going to happen. So I've set it to go up by 1 megahertz per step. Let's go up. That's down actually. Let's go up. 101. It's got that. That's on 102. And this is saying 104. I'm just going to leave the trigger for now. The auto. That's on 103. This is still saying 104. 104, 104. Let's keep going up. 11, 12, get a bit more, 115. And I think now it's just starting to struggle, but we'll hit the auto. 2.5, 2.5, 2.5. Yeah, so it appears it can work at these high frequencies, but it's not very clear. We can see there's a signal there, but we can't see the frequency. At least not how it's set at the moment. Won't take it a long time this time. 0. So it appears that this will work up to 100 megahertz or so. Let's come back down a bit. 110. Try that. Let's come down to 100. Yeah, so just over 100 megahertz is basically the highest frequency I can actually get a consistent reading on the scope. Okay, I think some of that noise, by the way, is when I'm actually putting my hand on the cable that's coming from the power supply. It's introducing noise. Okay, I'll show you what I'm doing actually. So this is the power lead going to the bench power supply. It's effectively introducing noise into the signal because this is kind of isolated from ground. So I think that gives us a pretty good idea how this is actually going to operate in the field. I would say that if you're getting up towards the high end of the frequency range, it may well not give you an accurate reading. It seems very temperamental by, like I say, touching the power wire, which I'm doing now, but it will read it. I mean, clearly this is not a laboratory instrument. This is really a nice quick tool for on-site technicians and No doubt anybody's experimenting with the electronics unless they do it at very, very high frequencies. It's a handy little gadget, and I think that's what this is designed to be at that sort of $60 to $70 price point. Normally on my bench I would use my bench oscilloscope, partly because I have one, but there are occasions when I won't use the bench oscilloscope, and that's when I'm probing on high voltage things. So I have the switch mode power supply here. You guys, if you've watched my other reviews on various things, you will have seen this before. So this is actually a 12 volt power supply. I have no load attached at the moment. I've clipped my ground lead onto the hot ground, and then on this end of this little inductor bead I have my connection to the drain of the switching MOSFET in this chip. So with this particular power supply, when it's effectively running with no load, it kind of goes into a sort of a standby mode where the MOSFET is just switching sporadically enough to maintain the output voltage. And because of the sporadic pulsing, it's quite difficult for some oscilloscopes to actually trigger this and show what's happening. So let's see if this one can do it. Now, when you're doing this sort of work, you need to be very wary, because any metal work on the tool is effectively now connected to hot ground via this clip. That means it's alternately being connected to live and neutral 50 times a second via the bridge rectifier. So you do not want to be touching the hot ground, but we need to use that as our effectively 0 volts reference. So this is our reference point. We call it 0 volts, but your finger will definitely not call it 0 volts, so don't touch the metalwork. I would have liked to have seen more of a shroud around this part of the tool so that the scope lead inserts and you can't touch that. But having said that, this is not actually dangerous as long as you understand the risks and you actually think about what you're doing. So touching any of these buttons will be fine, but you don't want to be touching that. Okay, so it's as safe as touching this is. It's no more dangerous than this, but you do need to know what you're doing here. So let's switch this power supply on and let's see what the scope thinks of it. So straight away we see some pulses. Auto. We don't see anything. Ah, something happened there. Let's go auto again. Auto again. So this is doing what a lot of scopes do, which is struggling to trigger on this intermittent pulse that we have. I might get it. I have had it on some other scopes. Let's go again. There, did you see it? But it doesn't want to trigger on this. You saw it again there. Okay. I'm on 100 volts. You can see the trace now. Trigger. And it can't really trigger on that. Now I'm on DC volts. I'll try go to AC volts and see if it'll trigger again. Yeah, you see it there. Okay, so when we go to AC, you can see it. I've had to do this with other scopes. The fact this one struggles to do it is not particularly unusual compared to other ones I've tried. The other thing is to hit the trigger when you actually see that. Let's try it. Yeah, I've got it, okay. So you can see that the thing is kind of like sporadically running. Can we alter the time base on that a little bit? Yeah, there. That's doing a pretty good job of it, actually. Let's switch this off now. And you'll see that it continues to run for a while as the main capacitor is discharging. Until eventually the voltage, you can see the voltage on here, 270. Yeah, getting less, this is getting smaller. So you'll get to a point where eventually it will stop. Okay, That's actually working better than most of the handheld scopes I've tried. And if you guys have seen the other videos, I hope you'll agree with me. What I'm going to do now, and you can see it fire once more, is connect a load, some power resistors to here, and we'll try this underload. You can still see it's trying to switch as the capacitors discharge. So here's my load. You've probably seen this before. It's a pair of 20 ohm 5 watt resistors, or rather 15 watt resistors, wired in series, but there's wires attached, so I can actually use them both in parallel, giving me 10 ohms, or I can use just one, giving me 20 ohms, or both in series, giving 40. So I'm going to load this power supply with a single 20 ohm at 12 volts. That gives me about, well, let's think about it. 12 ohms at 12 volts would be 1 amp, 24 would be half an amp, so somewhere a bit in between, 20 ohms, probably 600 milliamp or something like that being drawn from the power supply. Okay, so I've attached the load to the power supply. Let's switch this on. And now it's running, and you can see that this scope triggered straight away because the output MOSFET driving the transformer is running continuously now. There's a bit of ripple in that, and that's not a fault in the oscilloscope. It's literally because it's altering the width a little bit because it's continually monitoring the output voltage. And you can see about 370 volts. So it definitely works well on something like this. I can also try changing the trigger level as well, which I could have done previously, but it was working pretty well. So yeah, these set the trigger. So I've moved the trigger point down here now. That's actually given me quite a nicely triggered waveform. The fact you've just got these extra buttons for the trigger is nice because you don't have to kind of go into some mode. You've just literally got now here amplitude, time base, and trigger level. And that's a nice user interface for one of these push button operated scopes. So what I do like about this, it's small. The battery, well, it hasn't drawn anything off the battery while I've been trying this for about an hour. It doesn't seem to have made any difference. It will operate somewhere near to the 120 megahertz. It seems to work reasonably well, at least up to 100. So for such a little handheld instrument and such an inexpensive instrument, I think that's actually pretty damn good. The user interface I do like quite a lot. We also have a signal generator built into this. I haven't played with this. We'll just have a quick look at it. But what we can do with this, as I did with the previous instrument that I actually reviewed, is on the live stream, which is the following Sunday, 1 week today, with Detlef and Carlos on the electronics channel. We'll play with this. So anybody who wants to see a bit more with this, get onto the live stream, let us know what you'd like me to try with it, and we can try. To get into the signal generator then, we press the menu key and we'll have an option for signal generator out, I think. Yep, that one. Okay, so we're now on the signal generator. We can now select a frequency, so we press F1 and this gives a list of preset frequencies up to 5 megahertz. So it's not a continually variable signal generator, but you can just choose to use a certain frequency. So for example, let's go to 5 kilohertz. Okay, yeah, it's now set to 5 kilohertz. F2 will allow us to choose one of these output voltages. Yeah, and then mode OK selects between the different waveforms we can see there. So the signal generator is fairly simple to use, I will actually say. Again, this is something that we can play around with on the live stream if you'd like to see a bit more of this instrument. So I've reviewed a few of these things now, and I think they generally have their own kind of like quirks or personality. Given the price of this one, I'm going to give this a thumbs up. Yeah, this one gets my thumbs up because the user interface is nice. You don't have to press many keys once you understand what does what, like the trigger level, for example, and mode changes the waveform. Once you know which button does what, it's a kind of a single press to get into most things, rather than having to do like multiple long and short presses and go into menus just to do something like, for example, change the trigger level, yeah? So, user interface, I have to give this kind of like at least a 9 out of 10, I would think. I can't think there's any way I'd particularly improve this user interface given the buttons that are on here. It's fairly consistent. I mean, we could, for example, put like wave against this one, you know, just to tell you. But it's a good interface, really. The screen display is really sharp. I mean, considering, again, as you guys may well know, I get a lot of reflection from the overhead lighting on my workbench. The lighting is very bright. This really is sharp. And I'm going to give it an extra point for actually having a proper on-off switch. You just don't see that these days. And to me, that's just like common sense, yeah? So, you guys tell me what you think. But yeah, quite like that one. Especially given the price it's at for the performance I got out of it. Up to about 100 megahertz. Okay, so if you're interested, get into the video description down there. There are some discount codes and links in there which you can have a look at. While you're down there, get into the comments, let me know what you think of this. And I hope you enjoyed that, and I look forward to seeing you all again on another Learning Electronics Repair video. Ciao for now, guys.